In CIST 2611, Chapter 11, we'll look at VPN technologies. So, in this chapter, we're going to look at the essentials of virtual private networks. We'll look at some common VPN technologies and the core aspects of their implementation and management. We're also going to cover the differences between software and hardware VPNs. We're going to look at the secure remote access protocols like IPsec and SSL. We'll also discuss strategies for overcoming VPN performance and stability issues. And lastly, we're going to touch on VPN virtualization in this chapter. So first, we're going to distinguish between software and hardware VPN solutions. So software VPNs are often integrated in the server operating system. So they're available as part of an appliance OS, or they may be provided by a third-party software. On the other hand, hardware VPNs, these are standalone devices that are solely dedicated to managing VPN functions, including the authentication, encapsulation, encryption, and filtering. So these distinctions, this is going to shape how we approach our VPN deployment and the management. So we're going to look deeper into the nuances of hardware and software VPN solutions. Now, operating system-based VPNs, these are the ones that, such as running on your Windows or Unix operating systems. These are often the solutions going to be favored by smaller organizations. They are generally cost-effective. And they have many open source options available. Now, a potential security concern is that the server communicates directly with a public network. And they do this so the connections can occur. Now, a module-based VPN, this operates as a components on larger systems like firewalls or routers. They offer reduced complexity and are typically more affordable than hardware VPNs. The distinctions are important when deciding which type of VPN solution best suits your organization. We're now going to look at the hardware VPNs. So these are dedicated appliance-based solutions, often built in a router-type platform. Now, while they may be more complex to deploy initially, hardware VPNs offer greater scalability compared to their software counterparts. Additionally, they can be easily deployed redundantly, which enhances the reliability of it. Now, like any technology, though, hardware VPNs do have their vulnerabilities. One potential concern is the presence of the vulnerabilities in the VPN software code on that appliance. So, as with any security solution, thorough evaluation and mitigation of risk are essential when working with VPNs. Now we're going to look at the differences between Layer 2 and Layer 3 VPNs. First, I want to stress that it is important to understand that the protocols employed by most VPN solutions function at the Layer 2 and Layer 3 of the OSI model. Now, Layer 2 is also known as the data link layer. This handles the transfer of data from one VPN endpoint to another. An example of a Layer 2 protocol used for VPNs is the Layer 2 transport protocol. Now, on the other hand, Layer 3 is the network layer. It's responsible for end-to-end packet delivery. So this layer includes functionalities such as routing packets through intermediate hosts. For instance, the IPsec, the Internet Protocol Security VPN protocol. This operates at the Layer 3. So looking at the IPsec, this is a standards-based protocol suite that's crafted to fortify Internet Protocol communications. So its primary function is to authenticate and encrypt each IP packet within an IP data stream. And that ensures the robust security for transmitted data. Now, the IPsec operates through three main components, which forms the backbone of its security framework. So we'll continue with our look at IPsec. We're going to look at the components that fortify the network communications. First, we have the authentication header. This component provides integrity protection for the packet headers and data. Also, it ensures user authentication and can offer optional features like relay protection and access protection. Now, it is important to note, though, however, that the authentication header cannot encrypt any portion of the packet. Next, we're going to look at the encapsulating security payload. This plays an important role in authentication, ensuring integrity protection for the packet contents. Keep in mind, though, it does not extend this protection to the outermost IP header. Lastly, we're going to look at the Internet Key Exchange. This is a fundamental protocol responsible for negotiating, creating, and managing security associations. So, a security association represents a set of values defining IPsec features and protections that are applied to a connection. This acts as a backbone, ensuring secure communication establishments between the endpoints. Now, a couple of types of operation modes that we'll look at of the IPsec. First, we have the transport mode. This facilitates end-to-end communication between the host. In this mode, IPsec protects data traveling between individual endpoints. This ensures confidentiality and integrity. Now, in the tunnel mode, this extends beyond the host-to-host communications. This mode is commonly utilized for gateway to gateway or gateway to host scenarios. So it encapsulates the entire IP of packets within a new IP packet. So it essentially creates a secure tunnel between the participating gateways or hosts. Now, the secure sockets layer, we'll talk about this and its successor, the transport layer security. These serve as predominant alternatives to IPsec for your VPN implementations. So the SSL and the TLS, both of these function as the backbone of secure web communications. You may recognize HTTPS as the secure web protocol. So that transmits the data, encrypts the data that's transmitted over the web. Now, in the SSL/TLS, authentication is typically one way. This assures the server's identity to the client. However, it can also support bidirectional authentication through client-based certificates, and this provides an additional layer of security. So we're going to look at now how the SSLs and TLSs are leveraged in VPN deployment and how they offer distinct advantages over traditional methods. One is its cost effectiveness. So the SSLs/TLSs VPNs, they often have lower expenses compared to other solutions. Their platform independence, they offer the flexibility across various operating systems and devices. Users can access SSL/TLS VPNs from a wide range of clients. SSL/TLSs, the VPNs seamlessly navigate through network address translation barriers, so you have no problems with that. Administrators can enforce precise access policies that are tailored to individual users or groups. So the granular access control. Also, fewer firewall rules are required. So this simplifies configuration and management. The secure shell protocol. This is an important tool for secure remote access and network services over public networks such as the internet. Now, it serves various purposes. You have remote logins. So, with SSH, it enables secure access to a remote host shell. It replaces less secure methods like Telnet or RLogin. SSH allows executing single commands on remote host, and it substitutes the need for the RSH. Users can securely transfer files to remote hosts using SSH. The secure shell works in tandem with tools like rsync to back up, copy, and mirror files securely. Also, by leveraging the open SSH server and client, SSH can establish full VPN connections. And this can ensure a secure network communications. So the example here is PuTTY. So PuTTY is a popular terminal emulation application. This utilizes SSH to establish secure connections to the host, and that offers enhanced security and reliability in remote access scenarios. Now, ensure performance and stability are key considerations when implementing VPNs. So we look at some factors that affect both of these aspects. On the performance factors, the type of VPN being used, whether it's hardware based or software based or a specific protocol, that will influence the performance. The choice of the VPN protocol impacts performance. Some protocols may offer better efficiency and throughput. Both the server and client load can affect the VPN performance, especially when during the peak usage times. The configuration settings on the VPN clients. This is something else that can influence the performance. This includes the encryption settings and compression. Available bandwidth plays an important role in the VPN performance. That will affect data transfer speeds. The network topology, and this is included in the number of hops and routing path. This can impact the VPN performance as well. Another thing that can affect the performance is the level of encryption used in the VPN connections. So stronger encryptions typically require more resources. The volume and nature of traffic passing through the VPN can impact its performance. And also the version of the VPN client software that's being used may introduce performance improvements or even limitations. So now we're going to look at some of the stability factors, proper configuration of the VPN settings. This is something that is essential for stability. And this is including your authentication methods and security parameters. The physical location of the VPN servers and clients can influence stability due to network latency and reliability. Also, using the latest software versions of the VPN server and clients, this can help address known bugs and vulnerabilities. And finally, the underlying operating system. So the stability of that underlying operating system on the VPN servers and clients, that is something else that can also affect the overall VPN stability. So now we're going to look at the interaction between VPNs and network address translation, or NAT. This is something that is a common networking scenario. So NAT is the internet standard that allows organizations to use one set of IP addresses on their internal network while using a different set of IP addresses on their external internet connection. So this is something that's particularly useful when there's a shortage of public IP addresses. Um, Now that NAT device, and this is typically a router or a firewall, it's going to sit between the internal network and the internet connection. And it's managing the translation of all those internal IP addresses to the external ones. So it's going to serve as a mediator. It allows devices on the internal network to communicate with devices on the internet using the same external IP address. Now, that was developed as a workaround to address the limited availability of those IP4 addresses. Um, so there are two main types of NAT. You have your static NAT and dynamic NAT. When it comes to using VPNs with NAT, there are some challenges to consider, especially with IPsec VPNs. So, an IPsec VPNs can encounter difficulties when traveling a network that is using a NAT. Now, this is primarily due to the limitations in the IPsec standard. Now, a lot of VPN vendors have addressed this issue. They developed workarounds to address the issues between IPsec and NAT. So, to enable IPsec VPNs to function through NAT, you need to configure your firewall to allow specific protocols and ports. These include the Internet Key Exchange Protocol, which typically uses User Datagram Protocol port 500, Encapsulating Security Payload Protocol, and this could be identified by its IP protocol number of 50, and then the Authentication Header Protocol, and it'll be identified by IP protocol number 51. Now we're going to look at two different types of virtualization. We'll look at desktop virtualization and the SSL VPN virtualization. So first, with the desktop virtualization, using this approach allows you to create virtual desktop environments that are hosted centrally and accessed remotely by end users. With this type of virtualization, users can access their desktop environments from various devices, and it provides flexibility and ease of management. Now, looking at the SSL VPN virtualization, this provides secure remote access to network resources using the SSL protocol. So the SSL VPN virtualization, this involves creating multiple virtual instances of SSL VPN appliances or the servers to accommodate the needs of the different user groups and departments. Now, both of these, the desktop virtualization and the SSL VPN virtualization, they offer unique benefits and they play important roles in your most modern IT infrastructure. So in this chapter, we looked at the difference between software and hardware-based VPN solutions. Software VPNs they're often part of an operating system or they run as a third-party software, while hardware VPNs are standalone devices. The software VPNs may be less expensive and more flexible, while hardware VPNs are generally more scalable and offer better performance. We've also looked at the protocols used for secure remote access. The IPsec and the SSL are two common protocols used for VPNs. The IPsec provides secure communications at the IP layer, while SSL is commonly used for web-based VPNs. We also covered some strategies for overcoming VPN performances and stability issues. Some of the factors affecting VPN performances, they include the VPN type, the protocol, client configuration, bandwidth, and maybe the encryption level. Stability factors include the configuration, location, software version, and what is the underlying operating system. Finally, we discuss VPN virtualization. The desktop virtualization allows for the creation of virtual desktop environments that are accessed remotely by users, while the SSL VPN virtualization involves creating multiple virtual instances of SSL VPN appliances or servers to accommodate the different user groups and departments.